Hello and welcome to day 4. I believe that makes it, the 15th of December of the PiHut Maker Advent Calendar, Codemas, 12 projects of Codemas. And it's just me today, and we're going to get in number 4, box number 4, what's in the box. We have, hold on, the box design, I think, we've got chips, we've got, I suppose this is similar-ish. We've got what appears to be a cloud with some stuff coming out of it. Still love these box designs. Right, what's actually in here then? We have, potentiometer dial. I think we're going to go do some analog measurements. It's kind of sticking outside. Right, let's get to it. So, day 4, amazing analog. Okay, because we've been doing buttons, which you can kind of turn on or off. But this is going to give us something we can turn up or down or in the middle. So analog gives you somewhere between the on and off. So we've got a 10K potentiometer, there's a knob, there's a washer, there's a nut, and some jumper wires. Cool. So actually, this could be more like they say, digital as a light switch, but this could be part of a dimmer light switch. It could change how bright something is. And this is a variable resistor, so it's actually kin to the little blue components here. And while they reduce some of the current going to these LEDs, this will reduce, it'll change voltage and vary how much is going to an I/O pin. There are analog input pins on the Pico. So we'll slide the washer over the dial and screw on the included nut. So the washer and the nut, by the way, these are usually so you could put it inside a box, poke this through the box, and then bolt this down so the potentiometer stays inside the box for your control. So we'll turn the dial all the way to the left. Dial is down here. Leave the LEDs and ground wire in the blue lane in place, but remove all the buttons in the other part. Fine, we're going to remove the buttons. Looks like we're going to remove this as well. Grab the mini one and fit the potentiometer to the front end edge facing you. Oh, so we've got to actually take this mini breadboard apart. So much for my nice loom of wiring I made yesterday. We haven't got a mini potentiometer, we've got a big potentiometer. Fancy, your pins will have a hole space between them. That's right. Here, so we've got space for wiring. So we connect it to our circuit. So the right pin needs to go to 3 volts, middle pin to GPI 27 and the left to GND. I should be able to display them apart and push them in like that. There you go, nice and quick. 3 volt line. So yes, you could memorize where pins are and you could consult the Pico pinout, but if there's a good breadboard layout, you can save time by taking it. That one has gone to ground, one has gone to the 3 volts, and one has gone to an input-output pin, which is likely to be one of the analog pins. We're going to read the analog reading from this pin. We're going to print it out somewhere. Okay, so we're importing machine, but from machine, as well as the pin, we're picking up the analog digital converter. Time again, creating a variable for the ADC around this pin. We're reading its data, printing its screen, and then waiting a bit. Here's Thonny. Okay, hit the stop button, and there we go, it's connected. Day 4. Oh, I just called it day 4. Whoops. It's supposed to be day 4 ADC. I hit the enter key instead of my underscore. Right, but look, we've got 2 things going on here. We've got a graph, and we've got the actual numeric data, but I think the graph is more fun. And if I vary this, as I vary it, you can see the graph changing as I turn it. Now, it's a 1 second update, so it's not going to be that smooth. You can kind of feel the tick, tick, tick of the graph moving. But that's pretty cool. So the next activity is we're going to control LED flashes with analog values. I guess we're going to do how fast they flash. I know what I'm going to do after that, but let's try this. We've got a variable called my delay. We're going to have the red pin. That my delay is going to be whatever this number is divided by 65,000 is roughly a second, and so it'll be blinking depending on where we've set. Day 4 LED.py. Goodness, it saved so quickly before it didn't even stick the file name and thing. And we hit play. We have the LED blinking, and I can make it quicker and slower. I can make it so quick, as you just saw there, that it almost looks like it's completely on. I'll see what the next exercise is, but I am so wanting to put this into our Christmas lights where they spin, depending on how far we spin that. Okay, so the next example looks like we're going to use if statements. We're going to look to see, instead of if it is on or is off like the buttons, we're going to check if it's greater than or maybe greater than or equal to, less than or equal to a specific number. And that makes sense with analog. You really always only want to use greater than and less than, because if you try to say analog equals 10,000, you might find it quite hard to actually reach that number. So here we're using all 3 LEDs, and depending on the reading we get, we're going to change which LED is lit. So kind of, at the moment, it's connected to a potentiometer, but if you had this connected to something with, say, I don't know, measuring the strain on a sensor, you might have something that would allow you to perhaps, I don't know, rate how dangerous the pressure was. Day 4, if colors.pi. Ah, there we go. So now, and it's also running a much faster loop, so we've got a much smoother graph here too. That's cool. I'll put the LEDs next to the graph, except obviously the LEDs are so bright they make everything else look dark. Fader using PWM. Okay, so PWM, I've got another video on my channel talking about PWM, but it's a way of controlling the brightness of an LED. So you saw earlier how we were able to make the time faster or slower between blinks. But if you actually change how long a LED is on compared with off, you can change how bright it is. We've got the frequency, how often it runs, the duty cycle, how the proportion of on time to off time. PWM, which is another part of this machine library here. And we're going to wrap another pin, an output LED pin. We're going to set this PWM frequency to a fixed value, so 1000 cycles per second. And then based upon the reading, we'll set this duty cycle, on time to off time, and a really tiny delay. Okay, so the graph might have trouble keeping up with that. Are we printing it? Yeah, we're printing it. Day 4 PWM.pi. Start button. Okay, so that's really crazy, that graph, because it's updating a little bit too quickly. But look, as I turn that up or down, you can kind of see the brightness of the LED changing. And that's because it's changing how much on time it's giving in terms of power to the LED. That's PWM. Cool. Day 4 is complete. Yeah, well, I said we were going to do something fun with this. We're going to load from the Pico, which is now on the way. Day 3 button LEDs, where we've got all 3 of the LEDs. We're going to pick up the ADC pin as well. Day 4 Christmas lights. Alright. We're going to load day 2 blinky. That's the one that patterns the LEDs. While true, you have all the LEDs with their sleeps, but actually taking the same variable name, my delay. I'm going to put this up here and initialize that to nothing. And so we're going to do the same reading divided by 65,000. But now what we're going to be able to do is take my delay and put it where we've got, not there, where we say how long we're waiting. And I know these comments are total lies now, so we're going to remove those comments. I think we've got everything. So we'll save and run this. Okay, and if I change the dial, I can make it go slower or faster. That kind of hurts my eyes a bit, but that's quite nice. Cool. There we go. So we've now adapted the code, we made some changes to it. We talked about PWM and analog inputs. We've seen how this graph updates. Hope you enjoyed today's video, and go make stuff and be awesome. Bye.